Here we have a problem on integration, that is we have to evaluate this indefinite integral. Okay, let me start working on this. Okay, my first step, what I'm going to do is I'm going to write this e to the power of 2x along with dx. Then I'm getting just 1 over here, and here we have e to the power of 2x times dx. And also I write this 9 as 3 square positive. This e to the power of 4x can be written as e to the power of 2x times 2. Okay, integral 1 over 3 square positive. Here at the exponent, two quantities are multiplied, that is 2x and 2. Whenever two values are multiplied at the exponent, what we can do is we can take one of the values as the first exponent, and the other value can be taken as the exponent for the whole stuff. I'm going to take this 2x as the exponent for e, and I'm going to take the second value 2 as the exponent for the complete stuff. Then times e to the power of 2x dx. Even if I simplify this one, it will be equal to e to the power of 4x, because whenever we have some base and some exponent, and for the complete stuff again we have exponent, we can multiply the two exponents. When I multiply the two exponents, 2 and 2x, I'm getting 4x, that is e to the power of 4x. So this is equal to the original stuff. Okay, now let me consider a formula in integration, that is integral 1 over a square positive x square times dx. The result of this integration is 1 over a times arc tangent x over a positive c. Okay, now let's compare the integrand we have over here and the stuff we have over here in our integration. So here a constant a squared, here also we have a constant 3 squared. So here a single variable x is squared, but here e to the power of 2x is squared. Okay, if I want to use a formula over here in our problem, so a single variable has to be squared over here like x squared. But here we don't have single variable squared, we have e to the power of 2x squared. So now my aim is to get a single variable over here, so that I'll be able to use a formula that we discussed over here in our problem. For that, I'm going to do u substitution, that is I'm going to substitute a new variable u for this e to the power of 2x. Okay, let me do it over here, that is let u equals to e to the power of 2x. Okay, when I substitute a new variable u for this e to the power of 2x, I have to get this complete integration in terms of the new variable u. When I get the complete integration in terms of the new variable u, instead of dx, I must have du. So at the place of dx, if I want to get du, what should I do? So I have to find derivative of this u, so that I'll be getting du. Since we have the original integration with respect to the variable x, now we have to find derivative on both sides of this equation with respect to x. When I find derivative of this u with respect to x, I am getting du over dx. When I find derivative of this e to the power of 2x, still I am getting e to the power of 2x. By chain rule, when I do further derivative of this 2x, I am getting 2. Okay, now to get up the denominator dx over here, I multiply both sides of this equation by dx. Let me do it. So here this dx will cancel out. I am getting du equals to, we can write this 2 in front of e to the power of 2x, then I am getting 2 times e to the power of 2x times dx. Okay, when I consider the integration over here, here we have e to the power of 2x dx. Here also we have e to the power of 2x dx, but there is 2 multiplied over here. To get rid of this 2, I divide both sides of this equation by 2, then this 2 will cancel out. Then this du over 2 can be written as 1 over 2 times du equals to e to the power of 2x times dx. Okay, now let me go back to the integration. So let me continue over here. Integral 1 over 3 square positive. For this e to the power of 2x, I can substitute the new variable u, then I'm getting u square. And for this e to the power of 2x times dx, I can substitute 1 over 2 times du. Let me write it over here. Okay, let me continue. Okay, now let's consider the integrand over here. This part contains a variable u, and this complete part is multiplied by the constant 1 over 2. In integrand, whenever the complete variable part is multiplied by some constant, the constant can be moved out of the integration. So I'm getting 1 over 2 times integral 1 over 3 square positive u square times du. So I have moved this constant 1 over 2 out of the integration. Now let's consider the integrand over here. It's exactly in this form, 1 over a square positive x square. Now I can use the formula in our problem. Then we have 1 over 2 times. First we have to take this 1 over a. 1 over, instead of a in our problem, we have 3 times arc tan x over a. At the place of x we have u, and at the place of a we have 3, and I'm adding the constant of integration c. Because the given integral is indefinite integral, whenever I evaluate indefinite integral, after evaluation I must add the constant of integration. So the question says use c for constant of integration. So here to the result of the integration I have added the constant of integration c over here. Now let me continue the next step. 1 times 1 is 1, 2 times is 6, then I'm getting 1 over 6 times arc tangent. So actually u is a variable taken by us. It has to be replaced by the original stuff, that is e to the power of 2x. Let me do it. E to the power of 2x divided by 3 positive c. So this is the result of the given indefinite integral.